Let's look at the solutions of quality quant questions, week 21. This week, we again look at questions from triangles. First question. In a triangle PQR, PQ is 12 and QR is 4 root 3. The measure of angle PRQ is 60 degree. Then what is the ratio of end radius to circumradius of triangle PQR? Okay. Now, if you pay attention, you will be able to see PQ is 12, QR is 4 root 3. So the ratio of the length of the sides here is root 3:1. And opposite to PQ, you have the 60 degree angle. So very quickly you can come to the conclusion that this is a right angled triangle. This is 60 degree. This is 30 degree. Opposite to 30 degree, you have 4 root 3. Opposite to 60 degree, you have 12. So opposite to 90 degree, you will have 8 root 3. The ratio of a 30, 60, 90 triangle, the length of sides is 1:3:2. And then doing the working for ratio of end radius to the circumradius of triangle PQR is going to be very simple because we know it is a right angle triangle. Here the working would be end radius or right angle triangle is A plus B, 12 plus 4 root 3, A plus B minus C by 2 is 2. This is the end radius and circumradius is simply half the hypotenuse. So it will be 8 root 3 by 2. I can get rid of the 2's and I can make this into a 8 root 3 I will bring to the denominator. So it will be 12 minus 4 root 3 by 8 root 3. I can get rid of 4 root 3 from everywhere. So this will turn to root 3 minus 1 by 2. Root 3 minus 1 by 2. Now, when you look at the options, all the options have a third term in the denominator. How do I introduce that here? I would have to multiply this. I would have to rationalize this. How to rationalize this? I will need to multiply this with root 3 plus 1 and root 3 plus 1, numerator and denominator both. So this will turn to 2 in the numerator, 2 into root 3 plus 1. These 2's will get cancelled and the final answer will be 1 by root 3 plus 1. We can mark option B, but all of this hinges on us being able to identify it is a right angle triangle. Now, somebody who is unable to identify this is a right angle triangle, how would you go about solving this? We can also do that. Let's say this is the triangle. This is the basic formulation you see. Sorry, P and Q and R. Now PQ is given as 12, QR is given as 4 root 3, and this angle here is given as 60 degree. We can figure out the length of this side. Using the law of cosines. Cos 60, which is half, should be equal to 4 root 3 square plus k square. 4 root 3 square will be 48 plus k square minus c square minus 12 upon 4 root 3 into k into 2. So 8 root 3. Okay. This is where we should reach. So cancel becomes 4. I get, 12 square. Here it should be 12 square. So I will have k square minus 96 is equal to 4 root 3k or k square minus 4 root 3k minus 96 is equal to 0. Okay. Four root 3 into how much? 8 root 3. Oh, I need two numbers that differ by 4 that give me a product of two numbers that differ by 4 that give me a product of 32. 8 and 4 only I can think of. So see, if factorization here you can see it will be k square minus 8 root 3k plus 4 root 3k minus 96 is equal to 0, which will give me k taken out common, k minus 8 root 3 plus 4 times of, sorry, not 4 times, 4 root 3 times, and then it will be how much? K minus, if I divide this by 4, I will get 24, and divide it by root 3, I will get 8 root 3 is equal to 0, which gives us k plus 4 root 3, or k minus 8 root 3 is equal to 0. Either we break it down, factorizes it this way. Now, I know factorization with surds involved is not the simplest thing to do. So perhaps the most likely path that somebody would take from here is k will be equal to minus b. So 4 root 3 plus minus under root b square, which is 48, minus 4ac, which is minus 3 minus 4ac, which is plus 384, plus 384 divided by 2. So this will turn to 4 root 3 plus minus 432 is 144 into 4, so 12 root 3 by 2. Now see, 4 root 3 minus 12 root 3. If it was minus in between, the length of the third side will turn out to be negative. So that is not possible. So it has to be 4 root 3 plus 12 root 3, or 16 root 3 by 2, or the final value that k can take is 8 root 3. We somehow stumble into the value of k being 8 root 3. Once we have figured out the value of k being 8 root 3, now perhaps you can get to the conclusion that QR is to PQ is to PR is 1 is to root 3 is to 2. And then you get to your right angle version. If that would be wonderful, then if not, even if after figuring out the third side, you are unable to see that, there are other ways. For in radius, we know in radius into semi-perimeter is equal to area of the triangle. Area of the triangle would be half into QR into PR to sine 60. So semi-perimeter we have to figure out 12 plus 12 root 3 by 2. So 6 plus 6 root 3 will be the semi-perimeter. 6 plus 6 root 3. So R is equal to QR is 4 root 3 half into 4 root 3 into PR, which is 8 root 3 into sine 60, which is root 3 by 2. This whole thing divided by 6 plus 6 root 3. Okay. We can get rid of 2 and 2 with this 4. We can also get rid of this and, or let it stay. Let me not. 8 into 3 into root 3. So I will get 24 root 3 by 6 plus 6 root 3. I can cancel off the 6 and 6 with 4. So I get to 4 root 3 by 1 plus root 3. This is the in radius. This is the in radius. And circumradius working would be 12 into 4 root 3 into 8 root 3 by 4R is equal to half into ABC by 4R is equal to half into 4 root 3 into 8 root 3 into root 3 by 2. Half QR into PR into sine 60. Area in both these cases is identical. So 4 root 3, 8 root 3, 4 root 3, 8 root 3, 2 and 2 and 4. Root 3 comes down. R will turn to 12 by root 3, which is equal to 4 root 3. Now that I have my circumradius as 4 root 3 and my radius as 4 root 3 by 1 plus root 3, we can finally get to the ratio of 4 root 3. 4 root 3 will get cancelled. The ratio will be 1 by 1 plus root 3, which is similar to option B, and we can mark the answer here. I've taken multiple paths to the final destination here. I've taken multiple paths to the final destination because regardless of what your understanding is, as in what your initial trigger is, there are different ways of solving. For most quant questions, there are different ways of solving. It's not limited to just one way. Some ways are faster, some ways are slower. Whatever strikes you at the time is the right way. Don't always wait for lightning to strike for you to get to the perfect way of solving. But whatever strikes your mind and you're able to, of course, that should be correct. Don't randomly try to predict things. As long as you're sure what you're doing is right, please go ahead and solve the question and get it done. Moving on. Unequal side of an isosceles triangle is 2 centimeter long. Okay. The medians drawn to equal sides are perpendicular to each other. Find the area of the triangle in centimeters square. Okay. So let's say the medians drawn to unequal sides are like this. We know medians intersect each other in the ratio 1:2. So if I say one median is A is divided in the ratio A and 2A, and another median is divided in the ratio B and 2B, and the triangle gets formed something like this. A, let's call it P, Q, and R. PQ is equal to PR, which would imply the medians dropped on these sides will also be equal in length, which means it is not just A to A, it is also A and 2A here. So this is 90 degree and the unequal side is 2. So 2A square plus 2A square, sorry, 4A square plus 4A square is equal to 4. 4A square plus 4A square is equal to 4, or A square is equal to half, or A square is equal to half. This much we can infer. Now, for any triangle, if I draw 3 medians, let this be a median, it gets divided into 6 triangles of equal area. It gets divided into 6 triangles of equal area. And if you're being more interested in just the current shape that we have, lines joining the centroid, to the vertices divided into 3 triangles of equal area. So for this triangle, for this particular triangle, look at the area that we are getting. For this particular triangle, it is going to be half into 2A into 2A, or 2A square. It should be equal to 1 because A square was equal to half. So 2A square should be equal to 1. And this is 1/3 the area of the full triangle. So area of the full triangle will be 3 into 1. Or the answer to the question is option A. Answer to the question is option A. Okay. Next, in the below figure, AB is parallel to CD. AB is parallel to CD. AC is parallel to D. AC is parallel to DE. And FI is parallel to BE. FI is parallel to BE. Fi cuts the median AL at J and altitude DM at K. Fi cuts the altitude AL at J and, median AL at J and altitude DM at K. in the ratio of 4:3 and 2:1. Now understand this, given that all three sides, BE is pretty much the same side extended, and we are told that AB is parallel to DC and AC is parallel to DE. We can very quickly come to the conclusion ABC and DCE are similar. ABC and DCE are similar. Look at this. This angle here is going to be identical to this angle here, corresponding angles. Similarly, this angle here is going to be identical to this angle here, corresponding angles. So ABC and DCE are similar. Not only if they are similar, the lines present within them, are also going to be similar. So now, when I have this AL is the median and DM is the altitude. Both these lines, AL is also the altitude and DM is also the median. This is also true. AL is also the altitude and DM is also the median. It is not important or let's say conclusively proven that it is needed for this question, but you can come to that conclusion very quickly. Okay. Now this AL was divided in the ratio 4:3 and DM was divided in the ratio 2:1. Now see, FI to BE, the distance between two perpendicular points, the perpendicular distance between any 2 points for FI and BC will remain constant throughout their parallel lines. So if this length here is 3x, this length here will also be 3x. And if y is 3x, 2y will be 6x. 2y will be 6x. Okay. Now, finally, we are asked, what is the ratio of the area of triangle DHI? DHI, height is 6x, to the area of quadrilateral BCGF. BCGF. Okay. Look at area of ABC to DCE will be how much? ABC has a height of 7x. DCE has a height of 9x. So ABC by DCE will be how much? 7 square by 9 square or 49 by 81. 49 by 81. But now look at AFG. AFG will be similar to ABC. AFG will be similar to ABC and DHI will be similar to DCE, parallel line cutting across. So I can also go AFG by ABC is equal to 16 by 49. 16 by 49, which will give me BCGF. Let me name it this way. BCGF, because that is what finally the question was. BCGF by ABC will be equal to, from 49, if 16 is here, the rest should be here, 49 minus 16, 33 by 49. Now also let's look at DHI upon DCE will be equal to 36 upon 81. DHI has a height of 6x, DCE has a height of 9, 36 upon 81. And now, utilizing this and this, we can come to our final number. We want area of triangle DHI. DHI by DCE into ABC by BCGF. This is what we finally want. But So this should be equal to 33 by 49 into, sorry, this should be equal to ABC by BCGF gets me to 49 by 33 into 36 by 81 DHI by DC 36 by 31, and this DCE by ABC also we know to be 49 by 81. So you can cancel this. Final ratio of DHI to BCGF will be equal to 12 by 11. 36 by 33 gets reduced to 12 by 11, or the correct answer here is D. If we were a little I have not seen a lot of people being comfortable directly with writing stuff down. So what I would have done in an exam situation, okay, if this total area is 7x, so 49 I will take, so this will be 16, so this will be 33, total here is 81, so this will be 36, this will be 45, so I need a ratio of these two areas, so 36 is to 33. Directly I can write those numbers out, but here I also had to show you how those ratios are coming into being. Therefore, it took that much time. Otherwise, this can be done slightly faster as well. Okay, next. In an equilateral triangle ABC, PQR are midpoints of AB, AC, and BC respectively. Yep. Draw an equilateral triangle to the best of my ability. I have A, I have B, I have C. PQR are midpoints of AB, AC. P, Q, and R. Join PC and BQ. PC and BQ. Okay. And S is the intersection point. This point is S. Let AR meet PQ at O. Okay. AR meets. See, if this is a median, this is a median. The line joining AR will definitely pass through S. This point is O. Find the area of triangle ABC if area of triangle POS is 40 square. If the area here is 40, what is the area of the large triangle? Wonderful. Look at POS and OSQ. They are identical. They are identical. So the area here will be 40. Area here will be 40 as well. If POS is 40, SOQ will be 40. Now look at triangle PSQ and BSC. PSQ and BSC. These two are similar triangles. These two are similar triangles because this line joining the midpoints is going to be parallel to the base. So this angle will be same as this angle. This angle will be same as this angle. So on and so forth. No problem at all. Now, PQ's length is half BC's length. PQ's length by midpoint theorem is half BC's length. So if the area of PQS is 80, area of BSC should be 4 times of that, will be 320. And this is again wonderful. Given this is an equilateral triangle, S is the centroid, S is the orthocenter, S is the circumcenter, S is the incenter, everything. We have SBC as 320. So area for 1/3 of the triangle is 320. Area of the entire triangle will be equal to 960. 3 times of 320. And that's it. You can also, if you want a precise area of all these regions, you can also do that using what? Here we can do it using what is it known as? 1, 4. So 2, 2. This will be 160. This will be 160. Using a trapezium working. Hopefully we know in a trapezium, if we have something of this nature, if the area here is A, area here is B, the area here will be under root AB, area here will be under root AB. So if I have 32 here, I have 80 here. Let me write a combined 80. It is easier to see. I have a 32 here, I have an 80 here. 32 into 8 is 256. 0, 0 gives me a 0. So these two will be 116. Absolutely wonderful. So this bottom 3/4 the area of the triangle will be this much. So 1/4 will be how much? 1/3 of this summation. How much is this summation? I have 160, 160, 320, 320, 320 plus 80, 720, 720. 1/3 of this. The area here will be 240, or the total area will be equal to 960. See, all of it is different ways of approaching it, different ways of solving it. But of course, the final answer remains the same. Next question. In a triangle ABC, let angle C be 90 degrees. Okay. Angle C is 90 degrees. So this is A, this is B. So side opposite to A is A, this is B, this is C. Now, if R is the in radius and capital R is the circumference of the triangle, 2 times of R plus R equals. Now, if you're familiar with the formulation for right angle triangle, in radius, you've already used this in the first question. In radius will be given by A plus B minus C by 2, and circumradius will be equal to C by 2. So if we are looking at capital R plus R, we're doing capital R plus R, in radius plus circumradius, you will get A plus B by 2. 2 times of this, 2 times of this will be equal to simply A plus B, which is option A here, which is necessarily option A here. Now, in case we did not know this, in case we did not know this formulation, this one I'm fairly certain everyone knows. But in case you're not aware of this or right angle triangle, perhaps what you could have done, is take up a nice right angle triangle. The best nice right angle triangle we know is this one, 3, 4, 5. So let's see here, in radius will be calculated this way. In radius into semi-perimeter 6 is equal to half into 4 into 3, half into 4 into 3. So cancel, cancel, cancel. I get to 6, cancel. So in radius is equal to 1. So for this 3, 4, 5 triangle, in radius is 1 and circumradius is 2.5. So 2 times of circumradius plus in radius will be equal to 7. B plus A is indeed equal to 7. C plus A is 8. A plus C is same thing as C plus A. So this is also 8, and A plus B plus C is equal to 12. Among the 4 options, what works is option A. Then you should go back and update your list of formulae or learnings about geometry, that in radius is this, and move on. Okay. Next, XYZ is a triangle with sides. XY is 12, YZ is 10, and XZ is 11. YP and XQ are angle bisectors intersecting at R. Find YR is to RP. I will try to make a triangle diagram wise. Let's see, I have X, Y, and Z. This is 12, YZ is 10, XZ is 11. YP. YP will be like this, and XQ. XQ will be like this. We are told YP and XQ are angle bisectors. If they are angle bisectors, according to angle bisector theorem, XP by PZ should be equal to XY by YZ, or XP by PZ will be in the ratio 6:5, 12:10, 6:5. If 11 is divided in the ratio 6:5, XP is 6 itself, PZ is 5 itself. Absolutely wonderful. Then look at this triangle XYP. Look at triangle XYP. This is also an angle bisector. This was also an angle bisector. This is also an angle bisector for XYP. This is an angle bisector. So YR by RP should be equal to XY by XP, which is equal to 12 by 6, or the final ratio obtained will be what? We needed YR by RP only. So it will be 2:1, or option B here will be the right answer. Okay. PX and QY are medians of triangle PQR with lengths 18 and 21 units respectively. If PX and QY intersect at 90 degrees, find the area of this triangle. Okay. So if this is 7, this is 6, this is 12, and this is 14, and the triangle would get created somewhere, something like this. These two medians, X, U, Y, this will be R. Now again, because this is 90 degree, 14 into 12 is 168, half of that is 84. Area of, let's say, the centroid, I'm calling it at C. I'm calling it at C. TCQ, if the area is 84, this is 1/3 the area of the entire thing. So area of the full triangle will be 252, 3 times of 84. Next, ABC, the internal bisector of A meets BC and D. If AB is equal to 4, AC is equal to 3, and A is equal to 16, then the length of AD in centimeter is, let's say, I have in a triangle, something is happening. A, B, C. AB is 4, AC is 3, this is 60 degree. Prior to that, I will do one more wonderful thing, which will make this easy. Now I know what to do. Okay, let's say this is D. This is D. Because this is the internal bisector, can I say this is 30 degree? This is also 30 degree. Now, area for the full triangle ABC will be given by half into AB into AC into sine 60. Area for the full triangle. And this should also be equal to half into AB into AD into sine 30 plus half into AD into AC into sine 30. What this ensures is I can get rid of half everywhere. I can also now work my magic. AB into AC is 12. 12 times of root 3 by 2 is equal to 4AD plus 3AD by 2. So cancel, cancel. Or AD will be equal to 12 root 3 by 7, which is given in option B. Should be the answer. You can also go ahead and hopefully I know that we can figure out the length of side BC. We can also figure out the length of BD. We can figure out the length of side BC using the cosine law. We can figure out the length of BD using angle bisector theorem. We can figure out the length of BC using angle bisector theorem. And then again applying the cosine law with taking this SK, I can go ahead and solve for the length of AD. That is also another path existing. It is a lot of work. I'm avoiding it. Okay. In triangle ABC, the length of uh, side AD and AC are equal to 17.5 and 9 centimeters respectively. Sorry. My attention was gone. Let me make a triangle. AB is 17.5. AC is 9. Okay. Let D be a point on the line segment BC such that AD is perpendicular to BC. So this is the altitude. If AD is 3, then what is the radius of the circle circumscribing the triangle ABC? Okay. Now see, area of this triangle will be half into BC into AD, and it will also be equal to ABC by 4R, which is 7, sorry, AB into AC into BC by 4R. Now see, BC and BC, both sides numerator, I can get rid of it. AD, I need to figure out. AB is given to me. AC is given to me. Cancel, cancel. This becomes 2. AD is also given to me as 3. So it will become 3 is equal to 17.5 into 9 by 2. And R will come here. This R goes up here. This 3 cancels with this to give me 3. 17.5 into 3 is 52.5. By 2 will be 26.25. Or the circumradius will be option D, 26.25. Okay. Next, in square ABCD, a square ABCD is constructed inside a triangle PQR having sides 10, 17, 21 as shown in the figure. Find the approximate perimeter of the square ABCD. Okay. Now see here, this is a very, very useful triangle. Hopefully, we have come across this triangle earlier and are aware of how to handle this. This is what is known as a typical Heron's triangle. This is what is known as a typical Heron's triangle. What is meant by Heron's triangle is, look at this. Let's say this is 17, this is 10, this is 21. The perpendicular here is 8 because 10, 8 and 6 and 8, 17 and 15. Two right angle triangles that have a side common, one of the perpendicular side lengths being common. When they are pushed together against each other, they create a Heron's triangle where sides are different from, the length of sides is different from each other, and yet the area turns out to be integral. This sort of working is happening. Now 10, 17, 21 is a very common example of this. Although Heron's triangle by themselves are not common, wherever they come, 10, 17, 21 is a very common example of this. If you know this already, then your work is easy. Then your work becomes easy. If you don't know this, you can still figure out the height of the triangle or the perpendicular dropped from P is going to be what length? Let's say this point is N. Pn, perpendicular drop from P is going to be of length Pn. You can figure that out using the Heron's formula precisely. So area of this triangle will be half into 21 into Pn, which will be equal to under root of 48 ka half is 24, 24 minus 10 is 14, 24 minus 17, 7, and 24 minus 21 is 3. Okay. So we have to deal with this now. I will have 16, 8 into 2, 16, then 3 into 3, 9, then 7 into 7, 49, which turns to 4 into 3 into 7, or half into 21 into Pn. Is this much? 21 and 3 and 7 gone. Pn will be equal to 8. Then you can figure out your value of Pn and then proceed. That is also fine. But if you know Heron's triangles beforehand, it is easier. That said, Tn is, of course, 8. Now, ABCD is a square. Let the side of the square be A. The point where it cuts the square, let it be M. Mn will also be A. So, MP will be 8 minus A. 8 minus A. Okay. So, now I can simply do this. This full length, Pn by QR and Pn by AB. PAB has to be similar to PQR. PAB has to be similar to PQR. So 8 minus A, the length of PM by AB, which is A, has to be equal to the full length 8 by 21. So we get to 21 into 8, 168 minus 21A is equal to 8A. 29A is equal to 168, or A is equal to now you can do precise calculation and get to your value. That is fine, but you don't really need to do that because 168 by 29, can I say this is less than 6 and this is greater than 5? Finally, they've asked me the approximate perimeter of the square. Approximate perimeter, if one side is 168 by 29, the approximate perimeter will be 4 times of this. 4 times of this will be greater than 20 and less than 24. 4 times of A will be greater than 20 and less than 24. Among the available options, there is just one that satisfies the criteria, and that should be it. This should be the value of the approximate perimeter of the square. Next, PQRS is a square of side 8 units. Okay, let me draw a square. P, Q, R, S, M, N, O, T. This is N, and N is of QR, O, and T, M, N, O, T, PQ, QR, RS, and SP. Let QT and PO, let QT and PO. Okay. We need to join points now. What is this diagram? QT SN and of course MR RM. Okay, this gets created. QT and PO. QT and PO intersect at A. PO and SN intersect at B. And then SN and RM intersect at C, and this is D. Hopefully, with all this drawing and everything, you can see that the lengths of AB and BC and CD and AD are going to be pretty identical. All these lengths are going to be identical. There is nothing, there is not going to be a difference in these lengths. It's not going to be a difference in these lengths. But let's work more. Find the length of AD. Okay. First thing I'm trying to figure out is length of PO. Length of PO. This square was 8. PQRS had a length of 8. So if this is 4, this is 4, this is 4, PO will be equal to 8 square plus 4 square. So 4 root 5. This entire length will be 4 root 5. Okay. Additionally, how do I break it down? Oh, I can see MD. Look at triangle PQA and triangle MQD. PQA and MQD. MD is parallel, sorry, this line MR will be parallel to PO and M is the midpoint. So MD will be equal to half of PA. So if I take this length as X, this length here will be 2X. Okay. Similarly, if this length is, now see, whatever is the length of MD, TA will have the same length. This is X. This will be 2X. If this is X, this will be 2X. If this is X, this will be 2X. Additionally, X to X give me 4. X and 2X give me 4. Okay. Can I get to know one more wonderful thing I would have to figure out? Angle breakage, I would have to show that we are getting 90-degree here. Let's see. If I say this is X and this is 90 minus X. If this is X, this is 90. This is 90 minus X. Because this is 90, this is 90 minus X. And QT and SN are parallel. This is also 90 minus X. So this is also X. Oh, why am I using X again? X will be confusing now because it is also associated with length. Let's say if this angle was A, this angle will be 90 minus A. This angle will also be 90 minus A. Additionally, this angle will be 90 minus A. So mean this angle here is A. Okay. If this is A, this is 90 minus A. I am finding it difficult to prove to you that ABCD will be a square. I'm finding it difficult to prove to you that ABCD will be a square because I know it to be true simply by looking at symmetry. But how do I prove it conclusively? That is my challenge. Um, I know. Oh, I don't have to know. See this wonderful thing. MQD and PQA. If MD is to PA is 1:2. MD is to PA is 1:2. QD is to QA has to be 1:2. If this is 2x, this will also be 2x. Similarly, if this is 2x, this will also be 2x. If this PA is 2x, AB will also be 2x. And if RC is 2x, CD will also be 2x. And now one wonderful thing I can do, I know PO in entirety is equal to 5x. PO is 5x. 5x is equal to, this is 2x, this is 2x, this is x. This 5x is equal to 4 root 5. 4 root 5. So x will be equal to 4 by root 5. Now, when x is equal to 4 root 5, remember we were looking for length of AD. AD is 2x. 2x will be 8 by root 5 or option B. You can of course know this, that the figure that gets created here will necessarily be a square. The figure that gets created here will necessarily be a square. You can perhaps verify it from this. X was 4 by root 5, no? And this is 8 by root 5. Square of this will be 64 by 5 plus 16 by 5 under root SO length. We get to 80 by 5 under root, which is equal to under root of 16, which will be equal to 4 SO length. This angle here, all of them are going to be 90 degree only. Okay. Next one, PQR is a right angled triangle with PQ equal to 15 and QR equal to 20 and PB is equal to 4 units. Okay. This length is 15. This length is 20. So this length here will be 25. This is known. Now we are told PB is 4 and DR is 6. Now I'm saying if this is X, this will be Y, and this will be Y, this will be X. Because for the larger triangle, see, X plus 90 plus Y gives me 180. X plus Y plus 90 gives me 180. And X plus Y plus 90 gives me 180. This is simply a test on order of similarity. Do you follow the order in similarity? Now, opposite to 90, I have 25. Here, opposite to 90, I have 4. I need the length of PA. Because in order to figure out the length of AC, I need length of PR minus PA minus CR. So if I want length of PA, I need it opposite to Y. So for the large triangle opposite to Y, I have 15. So for the small triangle opposite to Y, I will have PA 5, 3, or PA will turn to 12 by 5, which is equal to 2.4. Same way, I need opposite to X working here now. 25 by 4 has to be equal to opposite to X in the larger triangle, I have 20. In the smaller triangle, I have CR. 5 and 4. I get to CR being equal to 16 by 5 or 3.2. So AC will be equal to PR. AC is equal to PR minus PA minus CR. 25 minus 2.4 minus 3.2, which will get us to 25 minus 5.6. I have made an error along the way. Opposite to this here is 6. This is not correct. This number is not correct. Neither is this number correct. Neither is this number correct. So we have to fix them. Be 25 by 6 here. So 6 into 4. So this will be 4.8. So 2.4 minus 4.8. So from here, what will be removed? Minus 7.2. So we get to 17.8, or option B will be the right answer. Okay. Next, ABC is a right angle triangle with AB as 6 units and BC as 8 units. If PQRB is a square, find its area. Okay. If this length is A, this length is 6 minus A. This length is A, this length is 8 minus A. Now, if this is X, this is Y. So this is Y, this is X. Opposite to Y, I have A. And opposite to Y, see, A, PQ and QRC have to be similar. Same set of three angles. So opposite to Y, I have 6 minus A. Opposite to Y, I have A. Opposite to X, I have A. And opposite to X, I have 8 minus A. So we can get to 48 plus A square minus 14A is equal to A square, or A will be equal to 48 by 14, which is equal to 24 by 7. Side of the square has been found out as 24 by 7. Area will be square of this, which is 576 by 49. Okay. Now in the given triangle, AH is to HC is 3 is to 1. This is 3K. This is K. This is 3K. This is K. And BC is to CD is to D is 1 is to 2 is to 3. This is N. This is 2N. This is 3N. Area of triangle BHC is 100 centimeter square. Area here is 100. Find the ratio of area of AHG to the area of triangle AGH. We need the area of these two triangles. Okay. Now, see this. Let the area of BHC, instead of taking it as 100, let me take it as a variable itself. Area here is A, but now BHC and BHA, BHC and BHA, the heights are identical, the bases are in the ratio 1 is to 3. The area here will be 3A. The area here will be 3A. Okay. Now, for ACD, can you see? For ABC and ACD and ADE, the area here, if it is 4A, for ABC, the area is 4A. For ACD, it should be 8A, and for ADE, it should be 12A. I'm just writing it down. ACD, it will be 8A, because the height remains the same, just that base has doubled, base has tripled. ACD will have an area of 8A, and ADE will have an area of 12A. Along the way, these descriptions should keep on working. Okay. Now, first thing I'm doing is I'm joining H with D here. H with D here, because see, here N is to 2N, area here should be 2A. Area here should be 2A. Okay. And then what is left here is 6A. So if I say this area is X, if I say this area is X, this area will be 6A minus X. Okay. Now see, for triangle ABH and triangle AHG, for triangle ABH and triangle AHG, the ratio of area ABH and triangle AHG, the ratio of area is 3A is to 6A minus X on account of bases being different. So 3A by 6A minus X, it should also be in the same ratio as BHD to DHG, because bases are identical here also. BH and HG are the bases. We are basically finding out the ratio of BH is to HG right now. We are basically finding out ratio of BH is to HG. This will be equal to 3A by 3a by x, which gives us x is equal to 6a minus x, or 2x is equal to 6a, or x is equal to 3. I'm doing my whole working thought process again. First, the area of BHC and BAH will be in the ratio 1:3 because the bases are in the ratio 1:3. Then I figured out ACD will have an area of 8A and ADE will have an area of 12A, because when the base is 1 and height is up till A, we get an area of 4A. So when base is 2 and height is up till A, we will get an area of 8A. When base is 3 and height is up till A, we will get an area of 12A. Then for ACD, I joined H and D. I joined H and D. If these two, see now for HBC and HCD, height is up till H, bases are in the ratio 1:2, so area should be in the ratio 1:2. I get A and 2A. Then for HDG, I took area of X, and therefore out of ACD, this is 2A, this is X. We know the total area was 8A, so this will be 6A minus X. Now looking at bases BH and HG. Now looking at bases BH and HG. For ABH and AHG, height is up till A, bases are in the ratio BH is to HG, which is 3A is to 6A minus X. Similarly, for BH and HG, BHD, the area here is 3A. For HGD, the area here is X. These ratios are supposed to be identical. If these ratios are supposed to be identical, we get X is equal to 3A, which means this is 3A, this is also 3A, which means BH is equal to HG. We have now come to the conclusion BH is equal to HG. Otherwise, ABH and AHG cannot have the same area. BH is equal to HG. BH is equal to HG. We have come to this conclusion. Okay. Finally, we need the ratio of AHG, which we have already defined in terms of 3A. So I should also go ahead and try to define AGF in terms of 3A. Okay. I know, look at this. Look at this here. Let me use a dotted line because it would be nicer. Area for DHE will be 3A. So then that bleeds into HDG area. I don't want to bleed into that area. I can do this. Sorry. I can join this line from G itself. For GBD and GDE, for GBD and GDE, the bases are identical. The height is identical, so area should be identical. Here the area should already be 6A. Here the area should already be 6A. And here the area, if I take the area here to be Y, the area here should be 6A minus Y, because we know ADE had a total area of 12A. If this is 6A, this is Y, this should be 6A minus Y. Now, again, utilizing the same logic, now I will try to figure out BG is to GF. BG is to GF. ABG, area of 6A, by AGF, area of 6A minus Y, should be in the same ratio as ABGE, area of 12A, and EGF, area of Y. This time it is slightly different, it is 2. So I get Y is equal to 12A minus 2Y, or 3Y is equal to 12a or y is equal to 4a. If y turns out to be 4a, then 6a minus 2y will turn out to be 2a. And then finally we can come to a conclusion. Ratio of area of triangle AHG to area of AGF. AHG is 3a, AGF is 2a. So the ratio of their area will be 3:2. This is perhaps the most difficult question in this sheet, or at least it was most difficult for me to break down. And hopefully this comparison of bases using area and construction, all of this was a good question for you. Okay. Three sides of a triangle are 8, 15, and x, where x is an integer. For how many values of x, the triangle is obtuse angle. Now this was a CAT question that had come in my first ever CAT, and I had gotten it wrong and I was extremely sad. And I remember the answer of this straight away. But there is fun learning here. Three sides of triangle are 8, 15, and x, where x is an integer. Now there are two cases to consider. First, where x is longest. When x is longest, there are two conditions in play. First is x has to be less than 8 plus 15, or x has to be less than 23. Other condition in place, because it is obtuse angle, x square has to be greater than 8 square plus 15 square, or x square has to be greater than 289, or x has to be greater than 17. So what are the acceptable values x can take in this range? It is going to be 18, 19, 20, 21, and 22, less than 23, and so on. This is the first case where x is the longest. The other case is 15 is longest. If 15 is the longest, 8 plus x has to be greater than 15, or x has to be greater than 7. This is the first constraint. Second, 15 square has to be greater than 8 square plus x square, or x square has to be less than 225 minus 64. So 25, 161, which means x has to be less than equal to 12. So what all acceptable values x can take here will be 8, 9, 10, 11, 12. We get 5 potential values of x from here. We get 5 potential values of x from here. So for how many values of x is the triangle obtuse triangle? There are 10 values of x for which it is obtuse triangle. Okay, next question. In the given figure, AB is equal to BC is equal to CD is equal to D is equal to EF is equal to FG is equal to G. Find angle A approximate to the nearest integer in degrees. Okay, we start off with AB is equal to BC. So if this is x, this is also x because AB is equal to BC. Now this is equal to CD. BC is equal to CD. See, if this is x, this is x. My external angle theorem should be 2x. Now if BC is same as CD, this will also be 2x. No problem at all. No problem at all. This will also be 2x. Now, CD is equal to DE. CD is equal to DE. But before I move that, can I see for triangle ADC, this is the external angle. So this should be 3x. This should be 3x. And we are told CD is equal to D. So this will be 3x also. This entire thing will be 3x also. Where I see two angles are getting combined, I write it outside. Now, FG, EF, sorry, DE is equal to EF. But I don't know this angle here. So I wait. I don't know this angle here. I could potentially write it as 180 minus 6x, but I don't want to write 180 minus something. I want to write everything in x terms only. Okay. GA Oh, look at this. Final thing. FG is equal to GA. If FG is equal to GA, this will also be X. Because FG is opposite is X, AG is opposite is X, which means this angle will also be 2X. Because for FAG triangle, FGC is the external angle, X plus X gives me 2X. Yeah. Anything else I can work out here? Okay. This angle will be 3X. This angle will be 3X. No problem. Anything else I can work out? I think I have EF is equal to FG. EF is equal to FG. Oh, if EF is equal to FG and I get 2X here, then this should also be 2X, which means this should be X. Okay. This should be 2X, this should be X. I can break it down nicely. Okay. What else? Okay. If this is 2X, this is 3X. This here should be 5X. If this here is 5X, okay. If this here is 5X, now see, it would imply this here is 3X because 2X plus 3X gives me 5X outside. 2X and 3X gives me 5X outside. And now look at this. EF and DE were equal. So for triangle DFE, this is 3X. This side should also be 3X. This angle here will be X. And now I have pretty much everything I need. Look at the large triangle ADE. Look at the large triangle ADE. I have X here. I have 3X here. I have 3X here. So 7X is equal to 180 or X is equal to 180 by 7, which should be equal to 25 whole 5 by 7. But then this was asked approximate to the nearest integer in degrees. So our final answer will be 26. Okay. Next, in the figure given below, ABC is equal to 45 degree and ACB is 120 degree and BC is equal to 20 centimeter. Okay, BC is equal to 20 centimeter. Okay, AD is drawn perpendicular on BC. AD is drawn perpendicular on BC such that it means BC produced at D. BC needs to be produced here and then AD needs perpendicular. Okay. Find the length in centimeter of AD. No problem at all. Can you see if this is 45? This angle here will also be 45. But prior to that, this will be 60. This will be 30. Let's say if this is A, this will be A root 3. This will be A root 3. Therefore, this will be 2A. And if this is, now look at this large triangle, this point, ADB. If 45 and 45 are the two angles here, A plus 20 has to be equal to A root 3. These sides have to be equal. So I get 20 by root 3 minus 1 is equal to A. Is equal to A. Now this 20 by root 3 minus 1, nothing is in the denominator in the options. So let me first rationalize it. I'll get 3 minus 2, 2 in the denominator and 10 times of root 3 plus 1 I will get 10 times of root 3 plus 1. But now we have gotten our value of A. What did we need? Value of AD. AD was A root 3. So our final answer, A root 3 would be equal to 10 times of 3 plus root 3, or option A will be the right answer. Okay. Next question now. The area for right angle triangle is 40 square centimeter, and its perimeter is 40 centimeter, the length of the hypotenuse. Okay. For the right angle triangle, can I go? This is A, this is B, this is C. Half into A into B is equal to 40, or AB is equal to 80. We know this much. Then we also know A plus B plus C is equal to 40, or A plus B is equal to 40 minus C. Now square both sides. We'll get A square plus B square plus 2AB is equal to 1600 plus C square minus 80C. Now A square plus B square for right angle triangle is equal to C square. So I can cancel this and this straight away. 2AB will be equal to 160. Comes over here, 80C comes here. I get 80C is equal to 1440. Cancel, cancel. Or C is equal to 80. The value of the hypotenuse is going to be 80. This seems like a geometry question, but is actually an algebraic manipulation question. Okay. One side of an equilateral triangle is 24. All sides of the equilateral triangle is 24. The midpoints of the sides are joined to form another triangle whose midpoints. So midpoints are joined to form a smaller triangle. Okay. Then their midpoints are joined to form a smaller triangle. Their midpoints are joined to form a smaller triangle, so on and so forth. Given that the subsequent triangle is being created by the same process, the common ratio that will get generated here will be identical. So I only need to figure out the perimeter for the first triangle, because one side is 24, perimeter for the first triangle is 72. And what is happening to the second triangle? If this length is 24, this length is 12, this length is 12, this length is 12. So perimeter for the second triangle is 36. So third triangle is 18. For the fourth triangle is 9. It is basically becoming half, and it is moving on infinitely. So sum of perimeters will be given by sum of an infinite GP, which is 72 by 1 minus half, or it will be 144, which is the answer to this question. Next, in the given triangle, BD is to DC 7 is to 4. 7K, 4K, AF is to FB is 1 is to 2. N, 2N, finally find FE is to EC. Okay. I know the area here will be 7A and 4A, and the area here will be Y and 2Y. Y and 2Y. Okay. FE is to EC is needed, no? Okay. I see that AE is to DE, ED. I can do AE is to ED in some manner, no? Because look at triangle ABE and BED. ABE and BED. I need ratio of AE by ED will be equal to 3y by 7A, 3y by 7A, by 7A, and here also the same ratio should get maintained. So if I say the area here is K, area here is K, it will be equal to K by 4A. Cancel, cancel. I will get K is equal to 12y by 7. K is equal to 12 by 7. Okay. I need FE is to EC. FE is to EC is known. Now look at AFE and AEC. AFE and AEC, that will be in the same ratio as FE by EC, which will be y upon 12 by 7y, which will be equal to 7 by 12, or option C will be the answer. All these questions in which angle area formulations need to be done, it is slightly tricky for me, or at least I have a eureka moment whenever I figure out what path needs to be taken. Okay, next. What is the minimum possible area in square units of the triangle ABC in the area of the triangle BRS and ABC are integers? If AP is to PB is to CQ is to QB is to PR is to RB is to QS is to SB is 1:2. Okay, look at this. AP is to PB is 1:2. So if this is 1, this is 2. But we are also told PR is to RB is 1:2. So if this is 1, this is 2. So PB can be broken down into 2 parts, can be broken down into 3 parts. All I do very, very quickly is let PB be 6. If it is broken down into 1:2, this is 2. And this is 4. And this is 3. And the same thing is happening on the other side as well. This is 3. This is 2. This is 4. Now, we are told area of BRS and ABC are integers. Given that same angle is being made here, same angle for ABC area would be 9 into 9 into sine theta, and for BRS the area would be 4 into 4 into sine theta, half of course on both sides. We can say the ratio of their areas is 16. BRS by ABC, ratio of their areas will be 16 by 81. And both of these are integers. Minimum value they can take, minimum value the areas can take will itself be 16 and 81. So minimum possible area of triangle ABC is going to be 81 itself. Okay. In front of a 200 meters long wall, a triangular plot is to be cordoned off using walls as one of the sides and fencing of total 300 meters to form the other 2 sides. So 200-meter wall, what was the work? Fencing of 300 meters. So this fencing, this length and this length is of 300 meters. So this will be 150, this will be 100, this will be 150, this will be 100. Then the maximum possible area in square meters of the plot that can be cordoned off. See, I'm not even working for maximum possible area. I'm directly saying it will necessarily be this way, where 150 and 150 get distributed equally on either side. 150 and 150, this 300-meter length fencing, 150 and 150 get distributed equally on either side, because otherwise the figure will not be symmetrical, the area will not be maximized, or can potentially look at it as, see, if I go 300 meters, everything is placed in one spot only. My base is fixed. My base is fixed, is 200. My altitude, if I take it as h, this will be A. This will be B. This will be 200 minus B. This will be 300 minus A. So B square plus H square is A square, and H square plus 200 minus B, 200 minus B whole square is equal to 300 minus A whole square, and we need 200 into H to be maximum. All that protestations aside, you should be able to directly come to the conclusion that both these sides have to be equal for the area to be maximized. Please, I'm not even getting into the nonsense of trying to prove it. Which will now lead us to maximum possible area we needed, maximum possible area. So if this is 150, this is 100, This is 50 into 2, this is 50 into 3. So this should be 50 root 5. You could also use your, what is it? Heron's formula in order to arrive at your result. But given it is going to be an isosceles triangle, 50 root 5, which gives us area as half into 200 into 50 root 5. So 5000 root 5 will be the answer. There is no way you can get any area larger than this here. Okay, next, how many scaly triangles are there for which the length of all the sides in centimeter are integers and perimeter is 24 centimeter? Okay, now see, the three sides are going to be A, B, and C. Wherein I'm taking this notation. A is the smaller side, B is the second smaller side, C is the longest. Now for the longest side, it has to be greater than 24 by 3. And it of course has to be less than, no, sorry, 24 by 2. Why it has to be greater than 24 by 3? Because it is the longest side. Even if I were to distribute equally among all three sides, it will be 8, 8, 8. So C has to necessarily be greater than 8. And then it has to be less than 24 by 2 because sum of any two sides of a triangle is always greater than the third side. So my C can lie in the range 8 to 12, or the acceptable values of C are 9, 10, and 11. This is my starting point. Okay, C is 9. B, I'm taking just lower 8, and A, I'm taking 9 plus 8 is 17. What does A need to be? It has to be 7. And there is no further exchange between A and B that I can make. That will get me to a new case. This is done. What if I take 10 here? 10 and 9, 19. So this should be 5. Now 9 and 5 can come closer to each other by 1. So this will become 8. This will become 6. This is 10. 8 and 6, if they come closer, any closer, they'll become equal. 7 and 7. So it will no longer be a scaling triangle. So no more cases here. Let's look at 11, 10, 11, 10, 3, 11, 9, 4, 11, 8, 5, 11, 7, 6. And this is it. No more cases available. I get 4 cases from here. I get 2 cases from here. I get 1 case from here. Or altogether, I get 7 cases for scaly triangles whose perimeters are 24 and sides are integer. Okay. In a triangle ABC, the length of side BC is 295. A, B, C. This is 295. The length of side AB is a perfect square. This is a perfect square. And length of side AC is a power of 2. This is some power of 2. And length of side AC is twice the length of side AB. Okay. So this is, if this is A, this is 2A. This is A, this is 2A. And this is also a power of 2. So can I say this is also a power of 2 raised to an even number? 2 raised to an even number. Only then will it be a perfect square. Okay. So now I have A plus 2A has to be greater than 295. Which means 3A has to be greater than 295. Or A has to be greater than 98 point something something. It also has to be a power of 2, but it has to be greater than 98. Additionally, A plus 295 has to be greater than 2A. Or A has to be less than 295. So I have A greater than 98 and A less than 295. This range, powers of 2 that exist are 2 raised to the power 7, which is 128. This cannot be A because A has to be some number 2 raised to an even power. 2 raised to the power 8, which is 256. And this is it. These are the only two numbers lying in this range. So A is this. So this side is 256. This side is double of that. So this will be 512. And now we have to figure out determine the perimeter of the triangle. It will be 512, 256, and 295. So 3, 1 carried over, 6, 1 carried over, 1063. Perimeter of the triangle will be 1063. Okay, last question. In a right angle triangle ABC, AB is 10 root 3 and BC is 20 and angle A is 90 degree. Okay. A is 90 degree. BC is 20. AB is 10 root 3. Root 3 is to 2. So this has to be 10. This angle has to be, 60. This angle has to be 30. All of this is instantly known because of the 30, 60, 90 triangle. An equilateral triangle ABD is constructed with base AB and with vertex D at a maximum possible distance from C. So on this side, ABD will be constructed. ABD will be constructed here. This is D. One side of ABD is 10 root 3. So this is also 10 root 3. Okay. Now we are asked find the length of CD. If I'm looking for length of CD, I will need to figure out this. Let's call this point M. Now DM will be half of BA. DM will be half of BA. So this is 5 root 3. This entire length is 10 root 3. DM will be 5 root 3, half of that. Now MA is going to be the altitude for triangle ABD. Altitude for the triangle is root 3 by 2 into 10 root 3. So it will be equal to 15. So this is 15. So now I have DM as 5 root 3, MC as 25. So DC should be equal to DC square should be equal to MC square plus DM square. MC square is 625. DM square is 75. So DC square is equal to 700 or DC is equal to 10 root 7 or option A is the correct answer. And that will be all for this week's quality quant questions. Hopefully you learned something. Next week, most likely we move on to doing more non-triangle based questions. Hopefully this was a fruitful exercise for you. That will be all.